Hello, remote learners. We are getting ready to do the outer planets. We have just checked our homework, so now we're getting ready for class, and here we go. All right. We're on page 94. Okay. Imagine you're in a spacecraft approaching Jupiter. Okay. You quickly discover that Jupiter is very different from the terrestrial planet. The most obvious difference is Jupiter's great size. Jupiter is so large that more than 1,300 Earths would actually fit inside of it. That's pretty big. As your spacecraft enters Jupiter's atmosphere, you encounter thick, colorful bands of cloud. Next, you will sink into a denser and denser mixture of hydrogen and helium gas. And eventually, if the enormous pressure doesn't crush you, you would you'll be ready to reach an incredible depth. It's an ocean of liquid hydrogen and helium.
Would it be liquid?
Okay? It's liquid.
Okay.
But where exactly is Jupiter's surface? It doesn't have one. It's gas. It does have the core. Okay? It has a solid core very deep within the planet. Okay? But by the time you reach the core, you would have been crushed by the pressures.
You would be a tin can on wheels.
Yep.
No
Okay?
wheels.
Jupiter and other planets farthest from the sun are called the outer planets. The four outer planets, of course, is Jupiter, Saturn, Uranus, and Neptune. And they're much larger and more massive than Earth and all the other terrestrial planets, but they do not have solid surfaces. Okay? Because of these four planets are all so large, they are often called the gas giants. Okay? You see in the picture up here, it kind of breaks it down, and I put it in terms that we can understand a little bit better. You'll see the distance from the sun. Jupiter is 779 million. Then you got Saturn is twice that far out. So you start to see how they're starting to get out. Jupiter takes about, when it's rotating on its own axis, it takes about 10 hours. So a day on Jupiter is about 10 hours long. Okay?
Hour night long.
A year is 12 Earth years. It takes it 12 Earth years to orbit the sun. To do one revolution around the sun. It's 12 years. Okay? Saturn rotates on its axis in about 10 hours and 45 minutes. Again, booking. Okay? But it takes it 29 years to do a revolution around the sun. 29 years. Okay? Because they're so far out and their elliptical orbit is so far that it takes it that long. Yes?
Isn't there like a thing where the planets are perfectly aligned for a little piece of time?
It happens.
Like how many years?
It doesn't happen very often. Not very often do the planets align like that. Yeah. Anyhow, Jupiter and the other planets, first and sun, are called the outer planets, the gas giants. Like the sun, the gas giants are composed mainly of hydrogen and helium. Because they are so massive, the gas giants exert a much stronger gravitational force than the terrestrial planets. Gravity keeps the giant planets gases from escaping, okay? Because they have so much of a gravitational pull that's what holds them together. It keeps the gas from just going floating off because gas is very light. Yes, spirits.
So, if like Jupiter or Saturn, if you opened it up, if you really counted the actual solid part, like the planet part of it, like ones that you can actually walk on, wouldn't it be smaller than Earth and stuff?
Probably not because they are so big. It would probably still be bigger than Earth, but it would not be massive by any means. I don't think. Okay. So despite the name gas giant, much of that hydrogen and helium is actually in liquid form because of the enormous pressures inside the planets. The outer layers of the gas giants are extremely cold because they're great distance from the sun. And temperature increases greatly within the planet. So as you start getting closer to the core, it starts to warm up. The outer region is cold. Okay? But that's because of what is creating the gases in that. Okay? All the gas giants have many moons. In addition, each of the gas giants is surrounded by a set of rings. And a ring is a thin disk of small particles of ice and rock and dust and things of that nature. Okay? A ring can consist of anything from as small as a piece of dust to as big as a mountain. The particles that are actually making up that ring. And all of these things has rings. All the gas giants has rings. It's not just Saturn. Okay? Saturn has the most and I guess the prettiest, if you would, but they all have them. Okay? All right, Jupiter on page 96. Jupiter is the largest and most massive planet. Jupiter's enormous mass dwarfs all the other planets. All the other planets, okay? In fact, its mass it's about 2.5 times that of all the other planets combined. So that gives you an idea of just how massive Jupiter is compared. You've got a little picture there that shows Earth compared to Jupiter on page 96. It's like a ping pong ball next to a overinflated basketball or something. Then you see the makeup of Jupiter. Okay, you've got a rocky core. Then you've got liquids, ice such as water and methane. Then you've got liquid hydrogen and helium makes up a good amount of it. Again, that's the liquid, okay? And then you got hydrogen and helium gas that makes up what we consider the surface, okay? So Jupiter's atmosphere, like all the gas giants, Jupiter has a thick atmosphere that makes up mainly of hydrogen and helium. An especially interesting feature of Jupiter's atmosphere is the giant red spot. You've all heard of that, I know. And that is a storm that is actually larger than Earth. Okay? The storm's swirling winds blows hundreds of kilometers per year, similarly to a hurricane. They estimate this thing is actually going something like 400 miles an hour. That is about twice as fast as a Hurricane 5, which is the most destructive hurricane on Earth. And it's going twice that.
Isn't there like a category 6?
No. Hurricane 5 is high as they go. Hurricane 5 is high as they go.
And if it was like, say we had to do that, if it would be double, wouldn't it be like category like 10?
Yes, but this is not a hurricane. This is just a giant red storm. Yeah. And it's not on Earth. So you can talk about Jupiter. Okay.
Well,
All right.
We have to settle Jupiter.
Oh, if you settle on Jupiter, then you just have to deal with the giant red storm, I guess. It's, But you can do it, Spears. I have confidence in you.
Yeah.
Okay. On Jupiter, there's no land to weaken the huge storm. A hurricane, even a Hurricane 5, when it hits land, it starts to weaken it as it goes across land. It slows it down and it weakens it. Okay, not saying it doesn't do massive destruction, but it does weaken. There's no solid ground here on Jupiter, so this thing just goes on and on and on because there's nothing to weaken it. Okay.
So it will go on
the-
for infinity?
Yeah, it's been going on. It was first discovered in the mid-1600s, and it hasn't stopped since, and it was going on before that. So, yeah,
So
it's
it's
going
going
to
to
go
go
on,
on for infinity.
probably. Yeah.
Until the sun goes kaboom.
Okay. Jupiter's structure, they think Jupiter is like other giant planets. It probably has a dense core of rock and iron at the center. It has a thick mantle of liquid hydrogen and helium. surrounds the core, and because of the crushing weight of Jupiter's atmosphere, the pressure at Jupiter's core is estimated to be about 30 million times greater than the pressure on the Earth's surface. 30 million times the pressure on Earth's surface. You think diving in 10 foot of water makes your ears pop?
Yours would explode.
Man, no, this would make your head explode. Okay? This would not be a pretty sight at all. All right. Jupiter's moons. Recall that Galileo discovered Jupiter's 4 largest moons. And these moons, which are highlighted over here on the next page, are Io, Europa, Ganymede, and Cassio. All 4 are larger than the Earth's moon. However, they are very different from one another. Since Galileo's time, of course, they have discovered dozens of additional moons orbiting Jupiter. Many of these are small moons that have been found in just the last few years, thanks to improved technology and all that stuff. But the biggest one, and this is the largest moon in our solar system, is Ganymede, which is larger than Mercury. Okay, so it's the big one.
Isn't Mercury the smallest planet though?
Mercury is the smallest planet, but it's still, you got a moon that is bigger than what we consider a planet. So, yeah.
How come a moon is not?
Because the moon's not a planet, the moon's a natural satellite. We will get into, I think, later, there's a test, basically, that everything has to pass in order to be a planet.
Wait, so a
Okay.
moon is considered
It's a satellite. It's a natural satellite.
a natural
It's a
satellite?
natural satellite. Moon is a natural satellite. Yes. Yes, Julia.
Is Mercury the smallest planet?
Mercury is the smallest planet.
Next to Pluto? Pluto is
Pluto's a dwarf planet. It's not
Okay,
considered
well,
a
if Pluto were
planet.
not considered a planet, would Mercury be bigger than a
Yeah. It was downgraded. It was downgraded to a dwarf. But yes, Mercury was larger than Pluto. Okay. All right. Now, let's talk about Saturn. The second largest planet in the solar system is Saturn. Okay. The Voyager probe that showed that Saturn, like Jupiter, has a thick atmosphere that is made up mainly of hydrogen and helium. Okay. Saturn's atmosphere also contains clouds and storms. It actually got a huge storm about twice the size of Earth going on at one of its poles. Saturn's atmosphere also contains clouds and storms, but they are less dramatic than those on Jupiter. Saturn is the only planet whose average density is less than that of water. Okay? Water on Earth, and I cannot remember my chemistry, but it's 1 centimeter gram/gram meter squared, something, I can't remember. It's been a long time since I had chemistry class. But anyway, basically anything that has more than a density of 1 will sink. Anything that's got less than a density of 1 will float. That's it. Okay? That's the way it works.
Wait, then how do ships float?
What?
How do ships float?
How the ship floats, because it's spread out a lot farther. We will study that in second quarter. Okay? But that's a very good question. Okay? When Galileo first looked at Saturn with a telescope, he could see something sticking out of the sides, but he didn't know what it was. Okay? What did he name those? Remember? Previous learning. What was it?
Maria.
Okay? No? What was it? You had the Saturn, you had the 2 things that bulged out on the side. He couldn't tell that they were rings. What did he refer to them as?
Little arms.
Ears. Yeah, he referred to them as Saturn's ears. I'm glad to know y'all were paying attention at some point in time. All right.
Hey, at least I used the body part.
You did. All right. But he didn't know what they were. And a few decades later, using better telescopes, they discovered that Saturn had rings around it. And these rings are made of chunks of ice and rock, and each traveling in its own orbit around Saturn. Okay? Now Saturn does have the most spectacular rings of any of the planets. From Earth, it looks like Saturn only has a few rings, and they are divided from each other by a narrow, dark region. But the Voyager spacecraft discovered that each of these obvious rings is divided into even thinner rings, and Saturn's rings are broad and thin, like a compact disc. So they're thinner, but they're stretched out. They're really big. Now Saturn's moons, Titan is the largest of the is larger than the planet Mercury. Titan was discovered in 1665, but it was only known as a point of light to this point until the Voyager probe flew by, and the probe shows that Titan has the atmosphere so thick that very little light can actually pass through it and escape. Okay? And then it's got 4 other moons of Saturn, are each over 1,000 kilometers in diameter. Saturn's got something like 50 moons, and the really cool part is some of them will be on the inside of the rings, and some of them will be on the outside of the ring, and they're kind of running close, side by side as they're going around. And they actually think it's that gravitational pull from these moons that helps hold the rings together and in place.
Because wouldn't they,
Isn't that cool?
like, wouldn't the sun be, like, slung out into space?
Some of it could be. Yes, sir. No homework tonight. Some videos. I will put the link in there for you. Start reviewing for your test coming up on Thursday, 10/8.